Okay, good morning. So, let's see whether I can get some more visibility on the screen, more or less. And first of all, let me recap our schedule for the next lectures. And I think you have received a mail from me with the calendar of the lectures, which is now summarized here. So tomorrow we start with 1 hour more, and I kindly ask you, because I couldn't find any room from 1 to 2 p.m. So what I propose to you is to start at 11 sharp, and then we make 1 hour lecturing and 2 hours with the PC. And we can stop at 1:15 if we make no break. And this is possible for you to start at 11 sharp tomorrow, the same room where we used to meet. Sorry, do you have any questions?
11 o'clock.
11 o'clock, yeah, sorry. Sharp means, I'm not sure whether it's American or UK English. In any case, this is possible. For you, it's possible.
Yes, we have a lesson earlier, so we
A bit late, okay. Okay, fine. So if you have a lecture earlier, we could also start with the PC. Would you prefer if we start with the PC and then the lecture at the end? I'm talking, sorry.
Yeah.
Would you prefer that we start with the PC and then, doesn't matter? Doesn't matter. Okay, that's fine. Okay, so I think it's better if we start with the lecture. And then we have next week an extra lecture. We have again May 15, May 22nd, 1 hour more. And probably it will be with the same schedule, 11, 1:15. And then we have May 17, 3 hours. And I think I'll find the room. Anyway, I'll tell you. Okay, for May 17. Okay, that's it. And for the exam, I just would like to kindly remind you that we agreed, if I'm not wrong, 2 dates. And the first date would be June, let me see, June 4, which is a Monday, at 9 o'clock. And this is a preliminary schedule if you would like to change the date, and then one other opportunity 1 week later, June 11. June 11 will be the official appeal, the official exam. June 4th is an opportunity for you if you want to anticipate. And then I think we didn't schedule any more, and we can schedule an additional one in the first week of July, if you agree, or the last week of June. It's your preference. So let's agree later, okay? Let's agree later when we finish the course in a couple of weeks, because so you have clearer ideas, okay? That's it. And one other question for you. Do you have any presentation to deliver? No. One of you contacted me but asked for the next week to deliver a presentation. And I would like to propose you this initiative, this idea for next Monday. Please be prepared when we start to ask one question at least each to me, okay? And the question can be whatever you think it is important, so related to the lectures that we have. So I would like to start with a question and answer session, about 15 minutes, next Monday. It can be a question related to the lectures that I did so far, or anything that you think it is important related to sustainable design of water resource systems. So water resource systems in a sustainability context. Whatever you think it is important, it should be a challenging question. So the idea would be that you ask me very tough questions, okay? It's not important if they are not tough. This is just the idea. And it's a kind of a game. I think it may be stimulating. You have 1 week to prepare, 1 question each. And if I cannot reply, which may happen, because of course the questions are general, and I may say I don't know, And I get committed for that 1 day later to provide the reply 1 day later. And we will see who wins, okay? So you give me 1 day time to reply if I have some problems. And then at the end of the story, you have to tell me whether my reply was satisfactory. I'll repeat tomorrow this, okay? I think it is a kind of a nice game. Let's try, okay? And of course, if you don't want, you can say I pass, okay? But I hope that you will not. Just asking a question is not a big problem. And I hope that you will not pass, but of course you can decide to pass, which means that I win, of course. Okay? That's great. And let's see how it goes. Everything is clear about this. Okay, you came late, but tomorrow I repeat this. Basically, prepare by next Monday a question for me, a tough one. Okay? Okay. And try to be specific, not like what is going to be in 100 years from now about water resources. So this is not specific, and this is not a really tough question, because it is a matter of opinion. So it should be specific in order to improve our knowledge, our technical knowledge. This is the idea. But again, don't be concerned. It doesn't have any detrimental effect on you. Okay? It may have a positive effect, because if the question is very good, and then we evaluate the questions. I just wanted to tell you that at the end of the subject, so end of May, I will make a reassessment of our interactive activities, and I propose to you how I can take them into account in your exam, and you are free to decide whether you want to take them into account or not. It depends, of course, on what I propose to you. If I say something like this can be valid for one question with the maximum of the mark, of course you will say, okay, perfect, because the exam is shorter and the first question is already gone with the max of the mark, so it's okay. I may say, okay, you have the option to take into account these activities as the first question with a mark of 27, and then you can say, no, I prefer not, and then no problem. If you prefer not, we make the classical exam, whatever. Okay, and if you have any idea on how to better take advantage from these interactive activities, just tell me. I am fully open. And at the end of the story, I think it will be an advantage for you, so don't be concerned, it's not detrimental. Okay, now let's go to today's subject. And today I have this idea. I would like to start talking about design. And I mean technical design, because we already talked about design during this course. We already talked about design because we talked about assessment of water resources availability. You know, when we talk about water resource systems, water resources availability is the first technical question. So far we talked about estimation of water resources availability with direct and indirect methods. And now I would like to speak about another technical issue, which is more related to design of infrastructures, and I decided to focus on river barrages. Why river barrages? I wanted to give room during this subject to discussing an infrastructure, at least one, which, I mean, infrastructures are not a central issue, a central item in design of water resource systems. Design of water resource systems traditionally is more like decision making, not really. So it's important. Typically, the typical question is: should I use surface water or groundwater in order to irrigate a field? This is a typical design of water resource systems. Another typical design is: okay, given that I have to give water to a certain city, what is the best option to deliver water, the cheapest one and the less environmentally impacting? These are decision-making issues. But sometimes technical design infrastructures are necessary. So I wanted to provide you with an example, and the typical example of infrastructure that is designed for bringing water to the water resources systems are river barrages. River barrages, their aim is to get water from a river. So it's surface water typically. Sometimes they are coupled with infrastructure that allow us also to take the groundwater in the riverbed. We don't speak about them. We just speak about river barrages. And again, the purpose of a river barrage is typically, not only this one, because they can have multiple uses, but typically the main use of a river barrage is to get water from the river. Okay, so let's talk about river barrages. And first of all, what is a river barrage? So I'm not using a PPT this time. I'm making reference to the lectures because, as you will see, there are some figures that are self-explaining, and I don't think we need a PowerPoint. It's not very... There are some issues where I need to concentrate your attention. I could, of course, copy them into a PowerPoint, but I think it doesn't give any more with respect to looking at the text here. Let me increase the font. Okay. So first of all, when we talk about a river barrage, we talk about a transversal structure along a river. So something that basically crosses the river, and it's a barrage. It's not a bridge, because also bridges are infrastructure that cross the river. In this case, when we build a bridge, of course, the purpose is completely different. It's usually transportation, and the main requirement of a bridge is not to interfere with the river. In the case of barrages, they are transversal structures, and their purpose is precisely to modify the dynamics of the river in general. So these are transversal structures, and when they can be called also retention structures. Retention means retaining water, retaining sediments. In Italy, we have a law that classifies the retention structures, transversal structures across a river, in 4 categories. And basically, they are dams and barrages. And the first 3 categories are dams. And the 4th is barrages. We will see the difference, okay? Talking about dams, they are classified in stone or masonry dams, earth dams, other types of dams. We are used to see, very frequently, stone or masonry dams. But earth dams are also very diffused. Earth dams have the advantage that they are more flexible with respect to a stone or a masonry dam. So when we work in an environment that is subjected to differential movement of the earth crust, like in the presence of tectonic movements, in all the situations when we believe that it's better to have a flexible structure retaining water, sediments, whatever, it's better to build an earth dam. Usually the earth dam is not overpassed by water, or if it is protected with concrete in order to prevent erosion. And the earth dam typically have a thickness that is much higher with respect to concrete dams. There are earth dams that are 300 meters thick, because of course you need a lot of earth in order to build a structure that resists to the water pressure. When we need instead a very thin structure, then we prefer concrete dams. We are not talking about dams in this course for one main reason. Today, it's not very frequent to have the opportunity to design a dam. The most important opportunities worldwide have been already used. There are some left opportunities, especially in the east of the globe, where in China, for instance, you may have heard that recently they built very huge dams. there are still some opportunities there. In the Western world, the opportunities for big dams are basically very infrequent. And therefore, there are some courses in civil engineering still focusing on dams design, but it is a very specific subject that it's interesting because, of course, it's a big structure, so it's an interesting issue. But on the other hand, it's a kind of background that is not frequently used. And therefore, we prefer here to focus on smaller structures like barrages because it happens quite frequently, even for a young engineer, to have the opportunity to design them. Okay, so there is only one thing that I want to talk about dams. There is also a second reason why today there is a lot of concern related to the design of new dams, which is the risk that they bring along and the environmental impact. The environmental impact is indeed massive, and there are several concerns today about the environmental impact of dams. Also, there is some risk. And keep in mind that the pressure of water, when you retain relevant heights of water, the pressure of water, which you know how to compute, it's extremely massive. It's an extremely massive driver, it's an extremely massive pressure that is exerted on the structure. And particular care needs to be taken. There are several examples of failures of dams, even in recent times, and also in Italy we had 3 examples of dams that collapsed in the past century. The most famously the Vajont Dam. By the way, if you get an opportunity to have a visit there, it's extremely interesting. So there are some of my colleagues that organize field trips with the students. But if you don't have this opportunity at the university, I suggest you to go there. It's quite close. It's 3 hours by car from Bologna, and it's a very, as I said, a very interesting. There is a museum there which is extremely interesting, and also going there, it's still today, after 55 years, it's still an interesting look and an interesting understanding. The other 2 dams were the Gleno dams, the Gleno Dam and the Gleno. You can search in Google for it. And the third was a dam in the Apennine, close to Piacenza. I don't remember the name. But anyway, if you go to Wikipedia, you find all the information. Before I move forward, I forgot to remind you that on May 21 we have our field trip, and I need to tell you where is the meeting point, and it will be at 8:30 in the morning. Please, if you can circulate a white sheet with the name of the students who are planning to attend, and one of you needs to make available a white sheet. I'm sorry, I don't have any with me. It's possible, perfect. And I need to know your name, your ID number, matricola, and your email, okay? And I will send also an email to remind you, but please, if you can circulate a sheet, and the same sheet will be circulated tomorrow. And if you know some colleagues that cannot attend today or tomorrow, please get their names and matricola, ID number, and you can subscribe them. And one thing, it will be, we will be back about 2 p.m., 1:30, 2 p.m. So no need to have lunch outside. Of course, we will make some break somewhere for the coffee, etc. But no need to bring food with you or to plan a stop in a restaurant. Okay, everything is clear. It's May 21. Yeah, 21. It's in 2 weeks from now. Okay. Yeah, today it's May 7, correct? Yeah. Okay. So dams, fine. Let's concentrate on barrage. And what is the difference between a barrage and a dam? Again, the Italian law specifies what is the difference. The difference is expressed in terms of technical behaviors, and in particular the height of the structure and the volume of water that is stored upstream. Because basically we can define a barrage as a small dam. The purpose is more or less the same, allowing us to get water, to store water, and to get it for using it for several different purposes. Several purposes are possible. The difference between a barrage and a dam is that the barrage is smaller. So what is, technically speaking, how is defined a barrage and how is defined a dam? So, the Italian law says that in order to classify a retention structure as a dam, either one of the two following requirements need to be met. The first requirement is that the height of the retention structure is higher than 15 meters in order to be classified as a dam. How do we measure the height? As usual, I forget to take a chalk, but I have some here. So if this is the riverbed and we build a dam here with foundations, we measure the height from the highest point that can be surmounted by water and the bottom of the foundations. For a barrage is at most 15 meters. So this is barrage. For a dam is more than 15 meters. Okay, and then when you build a dam, you have a storage upstream. This is the storage. And you compute the full storage, the max possible storage. Therefore, you put the level of the water at the highest point of the retention structure. And of course, a lake is originated upstream. And you compute this storage. So the storage for a dam, we have storage greater than 1 million cubic meters. And for a barrage is less. Barrage, storage, less than 1 million. As I said, if either one of these two requirements is met, we classify the structure as a dam. So even if it is 2 meters high, but the storage is 2 million cubic meters, then it's a dam. It's clear why we fix these two requirements, because when you have a very high water column, even if the storage is limited, in case of collapse, you get potentially disastrous consequences downstream. And the same for a structure that is not tall, but accumulates a lot of water upstream. In case of collapse, you have a lot of water running downstream with potentially disastrous consequences. So when we design a barrage, we take care of staying well below these two thresholds, 15 meters height and 1 million cubic meters. So what is the consequence in terms of management of this structure? If the storage, the upstream storage is limited, you understand that you cannot compensate mismatch between water demand and water availability over the long term. I try to be clearer. What is the purpose of a dam? One of the main purposes is to store water during the winter in Italy, for instance, in order to be able to deliver water during summer and to deliver water, for instance, for irrigation. So when there is plenty of water, we save it in order to distribute it when we are in the low flow season. But this means that we need to make a long-term compensation, where long-term is meant as a seasonal compensation. We accumulate in a season and we distribute in another season. But in order to be effective, this kind of long-term compensation needs a huge storage. Otherwise, if you don't have a huge storage, you don't get to the end of the low flow season with the water that you saved. If the storage is lower, you cannot compensate in the long term, but you may compensate during the day, because during the day you have the same mismatch between demand and availability. Typically, during the day, we need a lot of water. During the night, we don't need water. And during the day, typically, the flow in the river is the same day and night. It's the same if you don't have any influence of snow melt, which typically decreases during the night. In a typical river, mid-sized river, you have in all season the same flow during the day and during the night. We cannot say the same for water demand. During the day they are higher, and therefore we may need to accumulate water during the night in order to compensate the demand during the day. And this is a daily compensation. For the daily compensation, you don't need a huge storage. And this is why, in these cases, we prefer the barrage, which is less impacting, it's less risky, and may originate a storage upstream, which is less than 1 million cubic meters, but still allows a daily compensation. So what we try, the purpose of a barrage is precisely, one of the purposes is precisely to allow a compensation of the mismatch between water demand and water availability. In the short term, typically it's a daily compensation. Because you may say, okay, I can take the water from the river directly, I don't need a structure. Actually, you need a structure for several reasons. One of the reasons is precisely the fact that with a structure you can create a storage that allows you to better manage water resources. A second purpose of a barrage is to stabilize the profile of the riverbed. What does it mean to stabilize a profile? If you want to take water from a river and you want to take this water not just temporarily. If it is a temporary need, you can go there with a canister or with a tank, mobile tank, for instance, with tanks over a truck and get it. But if it is something that you want to plan for the long term, you need, for instance, to place pipes there and other structures that allow you to bring the water from the river to where water is needed. And during the years, the riverbed, due to erosion and deposition of sediment, changes its elevation. Sometimes significantly. After a flood, you may get a significant change of the river elevation. So if you place a pipe there and the elevation of the river changes, the pipe may become useless. So you want to build a structure in order to stabilize the riverbed. And this is another purpose of the barrage, to create a fixed point over the riverbed. A fixed point, a fixed structure, where you put in place the pipe that you need, the pipe or the canal. But the purpose is again to stabilize the riverbed. Barrages, in fact, can be built along rivers not only for getting water, but also for stabilizing the riverbed, or both of them. And in fact, if you go along a mountain river, you often see, especially in Europe, transversal structures. Sometimes they are devised for getting water, sometimes they are devised just for stabilizing the riverbed. And in this case, if the purpose is only to stabilize the riverbed, usually they are called check dams, or in Italian briglie. I want to show you a couple of examples of barrages, a couple of pictures, and there are links here in my web page to Wikipedia, and I'm not sure, let me, okay, this is, no, there is no higher resolution picture available, but this is an example of a barrage where the purpose is water withdrawal. Sometimes they are also built in order to ensure navigability of the river upstream, but in this case it's for water withdrawal. And let me see if there is something more. I don't think so. Let me see. This is another one. Maybe, okay, this is, okay, of course the visibility is not perfect because it's of the light. But in any case, this is another picture of a barrage that is conceived for water withdrawal. And probably in this case there is also a road crossing the barrage. Sometimes when the barrage is huge, we use them also for as bridges, basically. Let's see instead check dams, an example of check dam. This is a typical check dam. I hope that you can see the figure. You see that there are two check dams, and what is the purpose of these three of them, of these structures? Is to prevent river erosion, to stabilize the riverbed. And because in this case, by building these structures, you reduce the slope of the river. Because from a continuous slope, you turn the river into a sequence of jumps and reaches with lower slope, because some of the elevation gain is dissipated through the jumps, and therefore the slope of the riverbed is reduced. And this is done in order to reduce the energy of the flow and therefore reduce erosion. And also you have these check dams that act as they retain sediments, and therefore basically they stabilize the riverbed because they accumulate sediment upstream. So it's the opposite of erosion. And therefore they are used, as I said, especially in Europe, in order to limit the erosion of the riverbed. Look at this part, the central part that is placed at a lower elevation, and this is called in Italian gavetta. I don't think it has a name in English. And the purpose is to keep the flow far from the hill slopes in order to prevent erosion at the top of the hill slope, because then if the flow goes against the hill slope and you get erosion there, where you can indeed see some erosion, then it may trigger landslides, and then the landslides, it's a problem of course because of the stability of the hill slope up there, and also because landslides may block the river and originate storages upstream, and then when the temporary dam collapses, because it's a dam made by earth which is incoherent, when it collapses it may originate floods downstream. So I said that these structures are mainly used in Europe and not in other continents. What is the reason? Europe is small and has an orography that is very complicated. And therefore we need to protect ourselves against landslides, because typically we build houses very close to the river because we don't have room, and the complex orography makes hill slopes very steep, and therefore we get close to the river with the roads, with the houses, and we need to protect ourselves from landslides which are caused by river erosion. So this is why we intervene on the rivers and try to prevent erosion. If you go in the United States, they have a lot of room, the orography is less complicated on average, and therefore they don't have any need to get close to the rivers and protect themselves from landslides. They just get a little bit further away from the river, and they don't need to train the rivers in this way. This is called river training, when you plan a massive intervention in order to shape the geometry of a river. It's called river training. Okay, so we don't concentrate on check dams, but let's take into account that it's also our purpose when we design a water withdrawal to build a structure that stabilizes the riverbed, because if there is erosion, as I said, then getting water becomes a problem. So the purpose of the structure of the barrage is to stabilize the riverbed and to accumulate some storage upstream. Keep in mind that when you stabilize the riverbed, you also stabilize the water level. Once that you impose to the river a fixed geometry, for any value of river flow, you are able to determine a precise water level. And this is helpful because when you need to get water, you need to know what is the water level, and therefore it's very useful that you, in a way, stabilize it. Okay. So, design of barrages depends on several factors, which are, for instance, the geology of the place, the amount of the river flow to be withdrawn,